when any number is multiplied by the same number, the product is known as the square of that number. So the square is nothing but the multiplication of two same numbers. Hence, whatever methods we have applied for multiplication, the same methods are being used in this case. So like numbers near same base, but here both numbers are same, that means it is near base, near subbase and general. And in general also there are again two methods by using a ratio proportion method. That is using the Vedic formula Anurupena and a duplex method using the Vedic sub formula Dvandva Yoga. So in this case we are using a ratio proportion method because of subbase, and for base Nikhilam Navatascharamam Dashata. Especially for squares there is one more method where the number ending with 5. So let us deal with all these methods one by one. So initially the easiest of all is the number ending with 5. When we want to find the squares of number ending with 5, so 5, 15, 25, 35, 45, 55, 65, etc. are some numbers which end with 5. So what is 5 square? 5 square is 25. 15 square is 225. 25 square 625. And what about 35 square? So you will start thinking, but by Vedic method directly you can write it as 1225, 65 square and so on. So if we observe number which ends with 5 and its squares, you will find that when a number ends with 5, its square ends with 25. That means mentally we are prepared that the answer of this number, the square of this number, will end definitely with 25. Whatever is left is the remaining part of the answer. So except 5, what is left is 1, 2, 3, 6, 8, from which we got the values 2, 6, 12, 42, 72, etc. So how these values can be arrived at? The simple formula Ekadikena Purvena, or by one more than the previous one, is used. And here except 5, whatever is left, here it is 1, 2, 3, etc. multiply by their Ekadika, that is one more. So one more of 1 is 2. 2 ones are 2. One more of 2 is 3. 3 twos are 6. 3 plus 1 is 4. 3 fours are 12. Here it is 6. 6 sevens are 42. 8 nines are 72. So directly we can write 115 square. So it is 5 5s are 25. That answer is already there. Now it is only 11 into 12. So 13225. If it is 195 square if you want. So 5 5s are 25. 19 into 20, 19 to the 38 with 0, so 38025. So this quickly you can write the squares of numbers which end with 5. The study of numbers ending with 5 can be combined with this numbers ending with 0. That means squares of numbers 10, 20, 30, etc. which you can easily write 10 square 100, 20 square 400, 900, likewise 90 square, and so on, combined with 5 square, 15 square, 25 square, and so on. Only using the squares of numbers ending with 0 and ending with 5, you can write squares of any number, say between 1 to 100. So how to write those squares, that we'll see now. Let us say that you know the square of number ending with 0, that is say 20 square. 20 square is 400. If you know the square of 20, what would be the square of plus and minus 1? That is, plus 1 is 21, what is 21 square? Or minus 1, what is 19 square? So we will be using 20 square 400 as our standard, which is 400. So you write 400 in both cases. As the number is less than 20, its square will be also less than 400. Here 21 is more than 20, so its square will be more than 400. So by how much it is less and by how much it is more, that would give you the answer. And the answer is very simple. Just add these two numbers. So what is 19 plus 20? 39. You subtract and add it here. 20 plus 21, 41. So that 400 plus 41, 441 gives the square of 21. What about 19 square? 400 minus 39, which is equal to 361. Likewise, whatever number you can take, if you know 25 square, which is 625, what about 24 square? 26 square. So when we know the 25 square as 625, the adjacent numbers 24 and 26, how to find the square means 625. When the number is 24, the answer will be less than 625 by 24 plus 25, 49, and here the answer will be more than 625 by 25 plus 26, which is 51. So in this way, you can find out the squares of adjacent numbers to those ending with 0 and 5. Now suppose if at all we want (18 square and 22 square, which are 2 apart from the known square. That is, in this case 20 square is known. We want the square of 18, that is 20 minus 2 and 20 plus 2 as 22. So how to find? So again here also it will be 400 plus, because 22 is more than 20, and here also it is 400 minus. By how much it would be reduced here, or by how much it will be increased here. So 18 and 20, the gap number is 19. And it is 4 times the gap number, that is 19. Between 20 and 22, the gap number is 21. It is 4 times gap number. So 400 minus 19 for the 76. So the answer is 3, 2, 4. And here is 21 for the 84. So 484 is the square of 22. Same is the case here. If it is 23 square, 25, 26, 27 square. (27) being more than that by 25, its square will be more than that by 25 square, that is 625, and it will be less than 625 by which quantity, that we'll see. So 25 square is 625. We have seen how to find the squares plus and minus 1, that is 24 and 26. Now we'll go one more number beyond, that is 24 minus 1 is 23, 26 plus 1 is 27. So the gap between 25 and 27 is 26. The gap between 23 and 25 is 24. And this is 4 times 24. So 23 square will be less than 625 by 4 into 24, whereas in this case 26 is the gap. So it is 4 times 26. So whatever addition or subtraction you get, just by simple addition and subtraction, you can find the squares of such numbers. Now if you observe these two numbers, you can see 18 square, 19 square, 20 square, 21 square, 22 square, 23, 24, 25, 26, 27. Similarly, when you want 28, 29, it will be nearer to 30. So 30 is your target. And so 900 minus 4 times 29. 29 plus 30, 59. 31 square is 900 plus 61. 32 square is 900 plus 4 times 31, and so on. So easily you can find the squares of such numbers from 1 to 100, and beyond also you can use the same formula. So easily, only by knowing the squares of number ending with 0 and ending with 5, you can find the squares of any numbers in this fashion. So suppose if you want to find the square of 84. So 84 is a number between 80 and 85, but it is nearer to 85. So you know what is 85 square. It is 1 less, means minus. What is 84 plus 85? This is the value. Thus, we have seen, when we know the squares of number ending with 0 and ending with 5, how to find the squares of other numbers. And we have seen that how these values arrive at. So suppose if n is a number whose square is n square, which end with 0 or 5, we have found out n plus 1 and n minus 1. So what is n minus 1 square is n square minus 2n plus 1. Here n square plus 2n plus 1. And if we take this into bracket, it is and this into bracket. So n square, so number ending with 5 is n square, then ending with 4 and ending with 6, which is n square minus into bracket 2n minus 1, which is nothing but addition of these consecutive numbers, n plus n minus 1, that is 2n minus 1, and addition of these two consecutive numbers is n plus 1, it is 2n plus 1. That's why we are adding. Consecutive numbers for plus n minus 1. If it is plus n minus 2, n minus 2 square, and here it is n plus 2 square. Here n square plus 4n plus 4, which is nothing but n square plus 4 into bracket n plus 1, and in this case n square minus 4n plus 4 which is nothing but n square minus 4 n minus 1. So n minus 1, it is 4 times n minus 1, and n minus 1 is the gap between n and n minus 2, and here the gap between n and n plus 2 is n plus 1, and it is 4 into n plus 1. That's why we were multiplying by 4 and gap number, and here we are subtracting 4 into gap number. Squares of numbers near base and near subbase. It is same as multiplication of two numbers. The general formula for this numbers, squares of number near same base, is n square is equal to, answer is bifurcated in two parts. Left hand part is number plus deviation, the right hand part is deviation square. And how this formula is arrived is in the similar fashion, n1 into n2, we were doing d1 into d2, their respective deviations. So as n1 is equal to n2 is equal to n, so it is n in deviation is d, n deviation is d, because both numbers are same. So d1 into d2 is nothing but d square, and n plus d. So this is how the formula is arrived. In case of near subbase, you are multiplying left hand part by ratio. So we will multiply left hand part by ratio. So for near subbase, n square is equal to r into n plus d, d square. Rest conditions such as number of digits in d square part depending on number of zeros in the base, and deviation whether it is positive or negative, and write the values directly. So for example 107 square, in this case number is near 100, deviation is 7, so number is 107 plus 7 is the deviation, 7 square, so it is 11449 is the square. For example 1012 square, number is near 1000, deviation is 12, so 1012 plus 12 and square of 12, 144. Square of 13, number is near 10, so 13, deviation is 3, 13 plus 3 is 16, 3 square is 9, so 13 square is 169. If number is 94 square, now the deviation is negative, near 100, deviation is bar 6 or minus 6, so 94 minus 6, or you can write it plus bar 6 and bar 6 square. So plus bar 6 means 94 minus 6, 88, 6 square is 36. So 989 square. This number is near 1000. Deviation is minus 11 or bar 11. So 989 minus 11, 11 square. So likewise, we can write the answer directly. If it is say 994 square minus 6, 6 square is 36. It is 2 digits, but our base is 1000, 3 digits we need. So this 0 is very important because the base of this number is 1000. If it is 998 square, deviation is bar 2 or minus 2. 2 square is 4, which is single digit, and we want 3 digits, so it is 004. So 996004 is the square of 998. Suppose we want 14 square. Now in this case deviation is 4, 14 plus 4 is 18, and 4 square is 16, which is 2 digits, and as the base is 10, we want only 1 digit, so the second digit at tens place carried over to the left hand part, making it 196. If it is 15 square, 15 plus 5, 5 5 is 25, this 2 is carried over here. 16 square, 16 plus 6, 6 6 is 36. 18 square, 18 plus 8, 8 8 is 64. So likewise, we can write directly the values of squares. Suppose now coming to near base, when we want 21 square. Now 21 is nearer to 28 subbase, so which is 2 times 10. So R becomes 2. 21 is the number. Deviation from 20 is 1 and 1 square. So 21 plus 1 is 22 into ratio 2 is 44 and 1. So 21 square is 41. 18 square. We have already seen this using near base. Now we'll try this near subbase. So this number is near 20. So 2 is the ratio. 18 is the number. You have to add the deviation. Now in deviation in this case is minus 2 or bar 2. And bar 2 square. So 18 plus bar 2 means 16. 16 to the 32. Bar 2 square is 4. So 324. So either you can solve the example near base or by near subbase. Suppose if it is 307 square. So 3 is the ratio, 3 times 100, 307 plus 7, 314, and 7 square is 49. So 314 into 3 is 94249. So in this way directly we can write the answer. If the same is 3007 square, again it is 3 into 3014 and 7 square again. Seven square is 49, but it is 3000, which is 3 times 1000. So we want a 0. If we take 37 square, we want it is 3 times 37 is the number, deviation from 30 is 7, and again 7 square. So 37 and 7, 44 into 3, and 7 square is 49. Our base is 10. That's why we want only single digit. This 4 will be transferred over here. 1, 3, 6, 9. Now 37 is the number which is near 40 also. So we can consider 40 as subbase, which is 4 times 10. And from 40 the deviation is bar 3 and bar 3 square. It is 9. 37 plus bar 3 is 34. 34 into 4, 1369. 1369. So either you can use 30 as base and carryover will be there, or 40 as base without carryover. You will get the same result. Just for example, if it is 1,85,000 square is how much? So again here also it is n plus d. This number is nearer to 1,85,000 is the deviation. So n plus d means number plus deviation. We will have to add 85. And 85 square. Now you can use the other method, number ending with 5. So 85 square is 5 5 is 25, 8 is left, 8 9 is 72, so 7225. But our base is 1,00,000, so 5 digits are needed. 1 2 3 4 5. So extra 0. This is the answer for 10085. So now we can continue with the general method of finding out the squares. The Vedic formula Anurupena in Sanskrit or proportionately in English is used. So for example, if we want the square of 12, so first proportionately, just observe what is the ratio between unit and tens place. So it is 12, means 1:2 is the ratio. So if we maintain this proportion consecutively, we can write the numbers as 1:2:4:8, so that the consecutive ratio between consecutive numbers remains same. 1:2, 2/4 or 2:4 means 2 ones are 2, 2 twos are 4, 4 ones are 2, 4 twos are 8, so the ratio is maintained. Similarly, if it is 13, 1:3, so the ratio between any two consecutive numbers is 1:3. So So the procedure here for ratio proportion or Anurupada method is, whatever tens place number is there, digit is there, find its square. 1 square is 1. Maintain this ratio and write 3 consecutive numbers. So the ratio is 1:2, means 2:4. The ratio between first and second is 1:2. Second and third is also 2:4, means 1:2. Add the middle number. So 144 is the square of 12. Suppose if number is 21 square. Now the ratio is 2:1. Square of 2 is 4. Second number is half of first numbers. So half of 2 is 1. So half of 4 is 2. Half of 2 is 1. So the ratio between this and this is 2:1. Add the middle number. So 21 square is 441. So this part gives unit place. This part gives tens place. This is the rest, that is hundreds part. So when the square is, say, 2-digit number, unit place remains over, carried over will be there. Likewise it continues. So for example, 24 square. Now the ratio is 2:4, means 1:2. 2 square is 4. Double of that. Double of that. Add the middle number. So 16 means 6. Carried forward 1. So 576. So now the ratio was 1:2, 1:3. They were very simple ratio. But if the number is, say, 43, if it is 4:3, then how it is to be carried out? So for that it is very simple. It is nothing but square of a plus b, that is a plus b whole square, is a square plus 2ab plus b square. How this, in this form it arrives, let us see. Now we are considering 2 as a, 4 as b. We have taken the square of 2 and a. A means a square. The ratio between these two is a:b. To get the ratio, middle part is ab. So that a square upon ab is nothing but a:b. And the third portion is b square. So that ab upon b square is nothing but. So we have maintained the ratio a:b. We have added the middle figure, which is ab over here, and thus we get a square 2ab b square, which is nothing but a plus b whole square. So consider tens place as a, unit place as b, then write left a square, middle ab, and right b square, add ab, and proceed. So consider this as a, this as b. So a square means 3 square, a into b, 3 into 4, 4 square, add middle number. So 6, carry over 1, 25. So 1156 is the square of 34. Square. This is A, this is B. 7 square, 49. A into B, 21. 3 square, 9. Add middle number, 21. 9, 21, 21, 42. Carry over 4. 5, 3, 2, 9. 68 square, 6 square 36, 6 into 8 48, 64, 8 square, add 48, 4, 6 is carried out, 110, 4, 6, 2, 4. So this is how quickly you can find out the squares of any 2-digit number. So if the number is beyond 100 or 3-digit number, how to calculate? So we will take 105 square. The first method, number ending with 5. 5 5s are 25, remaining is 10. 10 into 11 is 110. So square is 11025. Second method, in this case, this number is near base 100, deviation is 5, and hence 105 plus 5, 110. D square means 5 square is 25. Now the third method, ratio proportion. Suppose this is A, this is B. Now A square means 10 square, A into B, B square, add middle number, 5, 2 is carried over, 10 is carried over, 11025. Third method. Fourth method, instead of bifurcating 105 as 10 and 5, we can bifurcate as well as 1 and 05. Now you observe B is 5, which is single digit. That's why while adding we were taking only single digit, carrying over the tens place. Now here B is 2-digit number. That's why whenever 2 digits are appear, it will remain. Third digit, if it is there, that will be passed on. So that now, what is A square? Here it was 10 square 100, but here it is 1 square is 1. Now A into B, 1 into 05, maintain 2 digits, 5 square, add 05. Now because B is 2 digits, you have to keep 2 digits. So it is 25, 5 plus 5, 10, and 1. Answer is 11025. So as far as possible, try to keep maximum number of digits in B, so that you will be keeping more number of digits in each session and carryover will be much less. Now in this case, you can bifurcate it as 2 and 014, or you can bifurcate as well 20 and 14. But this will be much easier. A square, A into B, and B square, add AB. So the answer is straight away we will get the answer. One more general method is there, that is known as a duplex method. In English it is known as duplex, whereas in Sanskrit the Vedic formula used is Dvandva Yoga. So if you observe the meaning of Dvandva Yoga, Dvandva, the meaning of Dvandva is either two or fight, and Yoga means combination. So it is always fight between two or combination of two. So how that combination or how the fight between numbers take place, that we will see, and by this we can find out the squares of any number. So let us see what is meant by duplex. Suppose A and B are two persons. It means it is two. They want to fight. So how they can fight? So first is A will start fighting with B. So A will start fighting with B, or initiation will be taken by B and he will start fighting with A. So A into B is AB. B into A is also AB, and it is the combination. So AB plus AB is 2AB. So duplex of AB is equal to 2AB. So we can consider A as one digit, B as another digit. So what is the duplex of 23 means 2, if this is A, this is B, into 2 into 3, 12. So 12 is the duplex of 23. What is the duplex of 41? Means 2 into 4 into 1 is 8. What is the duplex of 63? So I will be writing D for duplex. So D63 means duplex for 63. 6 3 is 18, twice of that, 36, and so on. So duplex of any two-digit number is twice of the product of those two digits. Suppose a single digit is there, 0 to 9, we can consider in general as A. So there is no fight. So when a single person is there, how he can fight? He has to fight with himself. That is duplex of A. A person has to fight with himself. A square. So duplex of 2 is 2 square. Duplex of 3, 3 square. Duplex of 0, and so on. Duplex of 3-digit number. It is not A to B into C, but this is unit place, tens place, hundreds place. Now we have to see that the fight will be there between two numbers. Now there are three numbers and we will be fighting whenever we have opposite opinion or difference of opinion. So in this case, first digit will fight with opposite A digit. So A will fight with C, and it is 2AC. Remaining is only B, and it is B square. So 2AC plus B square. So duplex of this. So duplex of 23. 2 into 2 into 3 is 12, and duplex of 1 is 1. So 12 plus 1, 30. Four to the 8 plus 3 3 the 9, 17. So duplex of 60 is 0, duplex of 1 is 1, So this addition can be done orally or mentally. So the same thing continues if the number of digits are more. For example, D, A, B, C, D, a 4-digit number. A will fight with D as 2AD, B will fight with C, 2BC. So if the duplex of 1, 2, 3, 4 is there, it is 4 to the 8 plus 3 to the 6 to the 12. 12 plus 8, 20 is the duplex. They are not squares, they are duplex. Based on this duplex, we can find the squares of any number. Like 6-7 digit number is there. So what is the duplex of this? A and G means 2AG plus 2BF plus 2C plus D square. So like that we can add all those mentally and write what is the figure for the duplex. Now based on this we can find the squares of any number into a single line. So what is 213 square? So just to understand, write D for duplex. Start with leftmost number 2 followed 21, add one more 213. So at the center you will get the whole number. Now forget 2, add leftmost, remaining is 13, forget 1, 3. Now what is the duplex of 3? 3 square. What is duplex of 13? What is the duplex of this? 3 to the 6 to the 12 plus 1, 13, carry over 1, duplex is 4 and 1, 5, so 213 square is, so 3041, what is the square? So initially you write D, start from 3, 30, 304, 3041, now whole number is there at the center, forget 3, forget 0, forget 4. Go on writing the duplexes and carry over the numbers. So 3041 square is 9247681. Here also when the number contains a digit higher than 5, that is 6, 7, 8, 9, you can convert it into vinculum so that your problem is much easier. So just we'll take one example. So duplex of 2, 29, 298, 98, 8. Duplex of 8, 64, carry over 6, 9 8 is 72, 144, 150, carry over 15, 81, 32 and 15, 138, 13 carry, 36, 46, 49, 4 carry, 2 to the 4 and 4, 8. 89804 is the square of 298. So now let us see what is the square of 189. The duplex of 1, 18, 189, 899. So duplex of 9, 9 9 the 81, carry over 8, 72, 144 and 8, 152. 64 plus 8 is the 64, 9 to the 18 plus 15. 9 is carried over, 8 to the 16 and 9, 25, 1 square, 1 and 2, 3. If the same, we can convert it into Wien coulomb as 2 bar 1 bar 1. That is 200 minus 11. It is duplex of 2. Bar 1 square is 1. Minus into minus plus. 2 into bar 1 into bar 1 is 2. This is bar 4 and 1 is bar 3. This is bar 4. This is 4. So 4 bar 4 bar 3. That means 400 minus 43, which is same as 357 followed by this 21. So 35721, 35721.